Thank you very much. Yeah, Stephanie, come to the stage, and also Johannes, also from Mercedes-Benz, both from Mercedes, as well as Mirco and Thomas from 7 Bell and 4 Silence. Why we are here today? We are here today because we want to speak about two amazing pilot projects 7 Bay and 4 Silence have initiated together with Mercedes-Benz about noise acoustics and noise detection. The headline of this panel today is about sustainable acoustics. Why is it relevant? Why we are here? Because all of you know car makes noise from, for example, tires, from, for example, the engine, and we need new technologies to reduce this noise, because every noise reduction technologies has also an impact on environmental protection. This is the one thing, and the other thing is if you want to install new materials, you need also new testing technologies to test those materials. And this is the other part. This is the reason why 7 Bell and 4 Silence are here, because they have these new testing technologies. The question is, what are these new testing technologies we need to, for example, lower the carbon footprint with new technologies for noise reduction in acoustics, and therefore 4 Silence, Mirco, what is about your technology?
Yes, thank you very much. It's a pleasure to be here. I'm working for Silence. We are a Dutch spin-off of the University of Twente, and we developed this small thing here. This is called the Sonocat, and acoustic is a very important topic, and car manufacturers like Mercedes are very looking deeply into acoustics, and we developed a measurement tool which allows you, or the average Mercedes customer experiences acoustics. So we developed a measurement tool which allows you to measure under real conditions while driving a car. So what does it mean? You can save a lot of material by knowing your problem. You can save a lot of time. It's quick and easy. And it's easy. You don't even need to be an acoustician. So a casual engineer can use it, I think. This is what we developed, and that's it. Thank you.
Thank you very much. Thomas, what is your solution?
Yeah, so at the 7 Bell, we provide our customers with measurement instruments that eventually make sound visible. So in our specific collaboration with Mercedes-Benz, we focused on localizing leakages in the car cabin. And for that particular reason, we put an ultrasound speaker inside the car cabin that is emitting a tone at 40 kilohertz, so outside of the audible frequency range. And with that particular device, we're essentially scanning the sound field that is leaking through doors, window ceilings, other structural elements, and can sort of visualize, very similar to a thermal imaging camera, where the sound is leaking through. And that, of course, supports engineers, when preparing vehicles for acoustic verification testing, but also in quality control to be sure that eventually everything has been assembled correctly.
Thanks a lot, thanks a lot. The next question we have for sure, now we have heard something about the technology. The point is what Mercedes did with this technology, and what is the difference to existing technologies of measuring sound, and why it is relevant for Mercedes.
Yeah, thank you. The difference is that, as you can see, obviously it's smaller and faster. And when we're doing sound cleaning at Mercedes-Benz, we are looking into every detail in the car. And so therefore, usually in the past, we used very bulky, a lot of effort put in bulky measurement systems. And it was very time-consuming to put all the measurement systems in the car, do the test drives. And as you can see, with the small devices, we are much faster and much more precise in locating either leakages or like where we have sound sources. And so we can apply insulation material more precise. And of course, we can use less material, which is a big contribution towards sustainability.
Thank you. And one follow-up question. What is one of the biggest learning you received into this project?
Well, for example, with the leakages, as you can see, it's connected to a smartphone. You have an optical device. You actually can see at one glance where's the leakage. And with the SonoCut device, it's like in real time you can find all the sound sources, and that's the reason why you're faster. And that's a big step forward for us in the sound cleaning development.
Yes, thanks a lot. And we also want to speak a little bit about what are the next steps, what is next, and therefore, Stephanie, maybe you can say a little bit about, now you have initiated 2 pilot projects, but the question is how the story will continue, and maybe also why it is so relevant for sustainability.
Yeah, thank you very much, Tim. So to make it short, the next step will be to confirm the benefit of the technology, what we saw in the pilot projects. I would say in a real car. We tested it in a real car, but in the actual development process. So at the early stage of the development process, and why is it so important? And where do we have the link to sustainability? Because at the first glance, testing method and sustainability, you don't really see the link. And let's start with the main target we have in the acoustic field. We want to make our cars quiet. This is an attribute that is historically linked to the Mercedes-Benz, and we want to keep this good NVH performance. And because it stands for luxury and comfort, that is the strategy of our company, as we heard from Ola Kalenius. So, and for achieving this good performance we already have in the cars, we have to use new material, sustainable materials that we probably don't know today. So this is the first aspect we have. We have to test this new material, yeah? And to see how they can perform the same way as the conventional material is using at the moment in the cars. So that's the first aspect. And the second aspect is the main, the best benefit we saw in these 2 technology, that with them you can look locally in the car at the areas or at the surfaces where you have the most potential for acoustic improvement. And in the history, we had other kind of testing, and you put material everywhere where you thought you have a source, or it could be the origin of the source. So let me say, it could be that in the past we made some over-engineering. So, and with this kind of tool, you can look very locally, and then you make you use less resources, so less material usage. So you have the first link to sustainability, and the second is, as I said, the topic with a new material, to test the new material and to compare there with the old materials to see how we can improve or keep the good acoustic performance. So to come back to the next step, so we will use it in the next car line we have, from the beginning to the lessons learned of the predecessor car line, and at every step of the development process to identify leakages or acoustic sources in the car. We are doing some electric cars, so this is also a topic there with the way of leaving the acoustic in an electric car. So it's quite another kind of perception you have in the car, and with this we can optimize very locally and very efficiently, very precisely, and very reliably, with a lot of reliability. So that was a very long answer, but I thought I have to focus on this cycle we have with the testing and the sustainability and the strategy we have in the company.
Many thanks for giving us those insights. And the last two questions are going to Thomas and also to Mirco. After you have heard those words from Mercedes and the trends you are observing in the market, what are the next steps for you? Thomas, how do you develop your product?
Yeah, so at this stage, our measurement instrument is predominantly used in product engineering for quick investigations. Going forward, we certainly would like to end up with this device on the shop floor in the production line, and that certainly requires some automation of the measurement instrument going forward. And this is what we are currently working on.
Yes, Mirco.
Yeah, I think we have a finished product. I'm very convinced. But of course, we are always doing developments. But that's the reason why we want to get in touch with companies like Mercedes or similar to hear from them, hey, what do you want us to implement in this sonocat? So this is more or less what we want and where we want to go to.
Does everything change for you, for example, when it comes to electric vehicles?
When it comes to?
Electric vehicles. Electric vehicles.
Yeah. Not for us, especially because we are just measuring in a real sound field, and but the sound field changes because a normal engine makes different sound to the inside of the cabin, and an electric car does not. So the sound changes, the experience for the driver changes. So that's something where I see, changing. Yeah. True.
Yeah, I think in using this kind of tool more intensively, yet in a development process, we will come to new ideas or new art of visualization or whatever. The product is standing, so I think the development of further software or whatever will not be a great difficulty. So it's the basis we start upon, and then we will see how it leads us. So I'm very excited.
Yeah, thank you very much. Unfortunately, our time is up. And with that, I said thank you